Gbogbo wa nílé lóko lẹ́yìn odi, mo kí wa pé a kú bójú ọjọ́ ṣe rí, mo kí ẹ̀yin ìyá, mo kí ẹ̀yin bàbá, mo kí ẹ̀gbọ́n, mo kí àbúrò. Èwo ni mo ní kí a jọ ṣe àgbéyẹ̀wò ẹ̀ lọ́jọ́ títí òní gẹ́gẹ́ bí mo ṣe promise nínú live program tí èmi àti Mr. Owóngorí-owó tí a ṣe. Now, àwọn àṣírí kan tó ń jáde síta tó dẹ̀ jẹ́ wípé gbogbo àwa tí a nífẹ̀ẹ́ sí ìran wa tá a mọ̀ wípé ọmọ aládé ni wá, ó yẹ kí a gbọ́ ká tún wá tọ́jú ẹ̀, ká tún jẹ́ kí àwọn ẹlòmíì tó mọ̀ wípé ó nífẹ̀ẹ́ ìran ẹ̀ kó share sí wọn, káwọn náà lè gbọ́. Irú eléyìí tó bá jẹ́ ọwọ́ àwọn ẹlẹ́sìn ló bọ́ sí, wọ́n máa pa á mọ́lẹ̀ ni. Bẹ́ẹ̀ ni, òyìnbó náà ti pa á mọ́lẹ̀ rí nígbà kan rí. Bọ́lá wípé àwọn ò mẹ́sìn jẹ́ nǹkan kan mọ́, òun ló fà á tí àṣírí yẹn tán lè fi máa sọ ọ̀n dẹ̀ dákẹ́ nínú research. Bẹ́ẹ̀ náà lẹ máa wá gbọ́ nǹkan tí Ìgbòho tí wọ́n sọ níbí báyìí. Tí ó bá jẹ́ pé gbogbo wa la padà sí ọpọlọ wa, tá lè mọ̀ wípé òkè kí ni orúkọ tí ewé yìí ń jẹ́. Ẹni tó bá dojú kọ mí, báwo gan lèmi gan, ìgbìyànjú wo gan lèmi lè ṣe láyé ara tèmi gangan, láti lè má jẹ́ pé kí ọwọ́ ayé ká mi, ẹ̀gbọ́n mi àtàbúrò mi, a máa gbọ́ bẹ́ẹ̀ ní nǹkan tí Ìgbòho sọ. Kó tó di pé a lọ gbé ti Ìgbòho wá, ẹ jẹ́ ká lọ gbọ́ nǹkan tí ó jáde láti àwọn tó ń ṣe research ní Amẹ́ríkà yìí. Àti arábìnrin yìí méjì ni, fídíò náà máa jẹ́ 3, pọ̀ mi ò wá ní jẹ́ kó pẹ́. Bọ̀ ẹ má gbàgbé láti bá wa pín, ẹ má gbàgbé láti bá wa share, láti fi kọ́mẹ̀ntì tiyín náà sí ìsàlẹ̀ tó bá jẹ́ nígbà àkọ́kọ́ ni.
Side of sub-Saharan Africa, you have some DNA from these other ancient human species, but if you're from within sub-Saharan Africa, you only have Homo sapiens DNA. Not quite. Those ghost lineages we were talking about, those ghost populations, well, they tell a kind of fascinating story. It turns out that there are some populations within West Africa that have ghost DNA. And that means that when the geneticists have looked at their DNA, they have seen that the source of the DNA in some populations, specifically the Yoruba and the Mende, come from a source that is not Homo sapien. It's not Neanderthal, it's not Denisovan. It's basically no human species that we have the genetic material of. It comes from a different ancient human species.
For more than 500 years, the origins of the Yoruba people have been one of the most debated questions in West African history. Historians argued. Colonial ethnographers built entire theories around it. Religious leaders disagreed with each other. Kings traced their authority back to conflicting versions of the same founding story. And no one, for hundreds of years, had a way to settle the debate using anything more solid than tradition, faith, or the assumptions of whichever outsider happened to be writing the history books at the time. Then geneticists opened up the genome. And what they found didn't just answer the original question. It uncovered something far stranger, buried far deeper, involving a piece of genetic code that scientists still cannot fully explain. It doesn't come from anyone's parents' culture, language, or recorded history. It comes from a species that has never been named, that left no bones, no fossils, no trace anywhere in the archaeological record, and yet lives on quietly inside the DNA of tens of millions of people alive today. Not a fraction of a percent. In some individuals, nearly a fifth of their entire genome. What they found didn't just answer the original question. It uncovered something far stranger, hidden far deeper, that no oral tradition, no historian, and no archaeologist had ever anticipated. This is the story of how DNA finally solved the Yoruba origin mystery, and the older, stranger mystery it accidentally uncovered along the way. To understand how strange this discovery really is, you have to start at the beginning, with a civilization, a sacred city, and a 500-year-old argument that no one alive could settle on their own. In 2008, when the International HapMap Project, and later the 1000 Genomes Project set out to build the world's first comprehensive map of human genetic variation, scientists needed reference populations from every major region of the globe. From West Africa, they selected a single group to represent the region's deep genetic diversity, the Yoruba people of Ibadan, Nigeria. The population is now known in genetics literature simply by its code, YRI, and it has since become one of the most extensively studied population groups in the entire field of human genomics. That decision alone tells you something. Of all the ethnic groups in West Africa, researchers chose the Yoruba as a genetic benchmark for the world. The 1000 Genomes Project eventually sequenced the genomes of over 2,500 individuals across 26 populations on 5 continents, cataloging more than 84 million genetic variants. And the Yoruba sample from Ibadan became one of the most heavily cited African datasets in the entire project. Every time a geneticist anywhere in the world needed a West African reference point to compare against European, East Asian, or South Asian populations, there was a strong chance they were reaching for Yoruba data. That also meant that when the deeper questions about Yoruba origins finally got asked, using real genomic tools instead of oral tradition or colonial guesswork, the data to answer them was already sitting in laboratories from Cambridge to California, waiting to be applied to a question 500 years older than the technology itself. It's worth pausing on why that mattered so much. For most of the history of human genetics, African populations were dramatically underrepresented in research databases, despite Africa holding more human genetic diversity than every other continent on Earth combined. Major early genome projects drew heavily on European and East Asian samples, and it took deliberate effort and projects specifically designed to correct the imbalance to bring West African populations like the Yoruba into the same level of genomic detail already available for populations in London, Tokyo, or Utah. That history matters here because it means the answer to the Yoruba origin question didn't exist for most of the 20th century. Not because no one was curious, but because the genetic infrastructure to even ask the question with any precision simply hadn't been built yet. To understand why the answer mattered so much, you first have to understand the size of the disagreement it was trying to settle. The Yoruba are one of the largest ethnic groups in Africa, with tens of millions of people across southwestern Nigeria, Benin, and Togo, and tens of millions more descendants scattered across the Americas through the transatlantic slave trade, from Brazil to Cuba to Trinidad, where Yoruba religious and cultural traditions still survive today under different names. In Brazil, Yoruba spiritual practice reshaped itself into candomblé. In Cuba, it became the foundation of Santeria. Across the Caribbean, Orisha worship, the veneration of Yoruba deities like Shango, Yemoja, and Oshun, continued for centuries, carried forward by people who were forcibly removed from their homeland, but never fully separated from it. Today, some scholars estimate that well over 100 million people worldwide have some connection to Yoruba spiritual and cultural tradition, which means the answer to where did the Yoruba come from isn't just a regional historical question. It's a question with genetic and cultural stakes stretching across 3 continents. At the spiritual and historical center of this entire civilization sits one city, Ile Ife. Yoruba oral tradition calls it the birthplace of humanity itself. And at the center of Ile Ife's founding story sits one figure, Oduduwa. But ask where Oduduwa actually came from and you get 3 different answers. And Yoruba, historians have never fully agreed on which one is true. The first tradition is purely spiritual. According to this version, Oduduwa was sent down from heaven by Olodumare, the supreme creator, descending on an iron chain with nothing but a handful of soil, a 5-toed chicken, and a palm kernel. As he descended, the chicken slipped from his grasp and began spiraling toward the ground below, In trying to catch it, Oduduwa let go of the sack of soil instead, and both fell together onto the primordial waters that covered the earth. The chicken scattered the soil across the water's surface, and where the soil landed, dry land formed, the very ground on which Ile Ife would be built. The palm kernel took root and grew into the first tree, its branches eventually bearing 16 palm fronds, said to represent the 16 original kingdoms that would one day descend from Oduduwa's lineage. From this act, Ile Ife was born, and from Ile Ife, all of humanity. In this account, the Yoruba are not migrants from anywhere. They are, quite literally, the people from whom the rest of the world descended. The second tradition comes from Samuel Johnson, a Yoruba Anglican minister, who in the late 19th century produced the first comprehensive written history of the Yoruba people, compiling generations of oral testimony into a single text after decades of research across Yorubaland. Johnson himself never saw his manuscript published in his lifetime. It was released posthumously in 1921, edited by his brother, and it remains, over a century later, one of the single most influential sources on Yoruba history ever written, ever. Within that text, Johnson recorded a very different version of Oduduwa's origin than the heavenly descent story, one in which Oduduwa was not divine, but a real historical migrant who left Mecca after a religious dispute, journeyed for 90 days, and arrived at Ile Ife carrying idols that were not welcome in his homeland. In Johnson's account, the founder of the Yoruba nation was an outsider, arriving from the Arabian Peninsula with a small group of followers and gradually establishing dominance over an already existing local population. The third tradition points in an entirely different direction, not Arabia, but ancient Egypt, or the kingdom of Meroe in what is now Sudan. Early European ethnographers and some Yoruba historians themselves proposed that Oduduwa and his followers migrated westward from the Nile Valley, carrying with them the political and religious sophistication of ancient Egyptian civilization, and that this Eastern heritage explained the complexity of the kingdoms that would eventually rise at Ile Ife and Oyo. This theory fit comfortably inside a broader intellectual framework that dominated colonial-era anthropology, sometimes called the Hamitic hypothesis, the assumption, now widely rejected by modern historians, that any sufficiently advanced African civilization must have been founded or influenced by lighter-skinned migrants from North Africa or the Near East, because indigenous sub-Saharan populations were assumed incapable of building such complexity on their own. That assumption shaped how European scholars interpreted the bronze work, the urban planning, and the political sophistication of Ife for decades, long before genetic evidence existed to test it. 3 legends, 3 points of origin, heaven, Mecca, and Egypt. And for hundreds of years there was no way to test any of them against hard evidence. Each version served a different purpose. The heavenly origin reinforced the sacredness of Ife and its royal lineages. The Mecca account, recorded during a period of growing Islamic influence in West Africa, gave the Yoruba monarchy a connection to the wider Islamic world. The Egyptian theory fit neatly, developing locally. Archaeology complicated all 3 stories long before genetics arrived. Excavations at Ile Ife uncovered extraordinary bronze and terracotta sculptures, some of the finest naturalistic portraiture produced anywhere in the medieval world, dating to roughly the 11th through 15th centuries, a period now referred to as Ife's classical age. The technical sophistication of these castings, produced using the lost wax method, was so advanced that early European observers reportedly struggled to believe they were made without outside instruction, an assumption modern archaeologists have since thoroughly dismantled through the discovery of local production sites, tools, and raw materials. Linguistic research pushed the timeline back even further, showing that Yoruba, as a distinct language, had likely been developing in place for well over 2,000 years, emerging gradually from earlier Mesolithic Volta-Niger populations already settled in the forest zone of what is now southwestern Nigeria, with the city-state at Ileife itself taking shape as early as the 5th century BCE. Instead of confirming a single foreign founder arriving to civilize an empty land, the evidence increasingly suggested something more complicated, a civilization that developed largely in place over an extremely long period of time, absorbing outside influences without being founded by them. But oral tradition, archaeology, and linguistics could only take the debate so far. None of them could definitively answer the most basic biological question. Where did the ancestors of the Yoruba people actually come from genetically? Were they, as the Mecca and Egypt tradition suggested, descendants of relatively recent arrivals from North Africa or the Middle East, layered on top of an existing population? Or did their ancestry run deep and local, tracing back thousands of years within West Africa itself, with no significant outside admixture at all? For that question, only DNA could give a real answer. The first major clue came from mitochondrial DNA, the genetic material passed down exclusively through the maternal line, generation after generation, largely unchanged except for the slow accumulation of mutations over thousands of years. In a detailed forensic genetic study analyzing the mitochondrial control region of 71 Yoruba individuals, researchers identified 65 unique mitochondrial haplotypes, producing a haplotype diversity score of 0.9976, a number so close to the maximum possible value that it places Yoruba maternal lineages among the most diverse of any population ever studied. This is consistent with a foundational fact of human genetics: interbreeding. When researchers calculated the FST between the Yoruba sample and a broader Nigerian dataset from the 1000 Genomes Project, the result was effectively 0, a statistically insignificant difference. When they compared Yoruba maternal lineages to a geographically close population in Ghana, the genetic distance was also extremely small and not statistically significant. In plain terms, on the maternal line, Yoruba ancestry blends almost seamlessly into the genetic landscape of the surrounding West African region. There is no sign of a distinct, separate maternal lineage suddenly appearing from Arabia or the Nile Valley. The mothers of the Yoruba nation, genetically speaking, look like the mothers of West Africa as a whole. The second piece of evidence came from a study comparing 5 major Nigerian ethnic groups: Yoruba, Igbo, Hausa, Tiv, and Ibibio, using 9 short tandem repeat DNA markers, the same kind of markers used in modern forensic identification and paternity testing. Researchers extracted DNA from blood samples of 250 consenting participants, sampled directly from their ethnic homelands across Nigeria, and compared allele patterns across all 9 genetic locations. The pairwise genetic similarity between Yoruba and Igbo populations came out to 0. 993, the highest of any pairing in the study. Yoruba and Ibibio scored 0, 990. Yoruba and Hausa, 0. 992 Yoruba and Tiv, 0, 987. By contrast, the Igbo and Ibibio populations, despite being geographic neighbors, showed the lowest similarity in the entire study at 0. 895, a reminder that geographic closeness doesn't always predict genetic closeness in the way people assume. When the researchers ran a full analysis of molecular variants known as A-MOVA across all 5 groups, the results were even more striking: 99. 98% of all genetic variation existed between individuals, regardless of ethnicity, while only 10% of variation could be attributed to differences between entire ethnic populations. Put another way, if you lined up 2 random Yoruba people and compared their DNA, there is a strong chance they would show more genetic difference from each other than the average Yoruba person shows compared to the average Hausa, Igbo, or Tiv person. Ethnic identity in Nigeria, the data showed, is a powerful cultural, linguistic, and historical category built on language, tradition, religion, and political history. But at the level of the genome, these populations are far more genetically similar to each other than distinct. That finding did more than describe modern Nigeria. It quietly undercut the premise behind both the Mecca and Egypt origin theories, which required Yoruba ancestry to be meaningfully distinct from surrounding West African populations because of a relatively recent, geographically distant founding migration. The genome showed the opposite, deep, long-standing continuity with neighboring peoples, not a layer of foreign ancestry sitting on top of a separate substrate. The third study went further and added a twist historians hadn't expected. Research remained rooted in their birthplace. The paternal picture told a very different story. Yoruba and Igbo, both speakers of Niger-Congo languages, were paternally correlated with populations who shared that same language family, regardless of geography. Hausa, by contrast, whose language belongs to the unrelated Afro-Asiatic family, showed paternal lineages more closely aligned with other Afro-Asiatic-speaking populations across Africa, including groups far outside Nigeria's borders, and displayed in February of 2020. Two researchers from the University of Southern California, Arun Durvasula and Sriram Sankararaman, published a study in the journal Science Advances that had nothing to do with Ile-Ife, Oduduwa, or the last 2,000 years of human history at all. To understand what they found, it helps to know something most people outside genetics don't realize. People with European, Asian, or Oceanian ancestry today carry between 1 and 4% Neanderthal or Denisovan DNA in their genomes, genetic leftovers from ancient interbreeding events that happened as modern humans migrated out of Africa and encountered these other archaic human relatives tens of thousands of years ago. For a long time, the assumption was that West African populations whose ancestors never left the continent carried none of this kind of archaic ancestry at all, since Neanderthals and Denisovans lived in Europe and Asia, not Africa. Using advanced statistical modeling on genomic data from 4 West African populations, Yoruba, Isan, Menda, and Gambian, Durvasula and Sankararaman set out to test that assumption directly. What they detected was something no oral tradition, no archaeological dig, and no historical document could ever have predicted. Buried within the genomes of Yoruba and Mendo individuals in particular, they found segments of DNA, between 2 and 19% of the genome, depending on the individual, that did not match modern human ancestry at all, and did not match Neanderthal or Denisovan ancestry either. This genetic material appeared to come from what researchers call a ghost population, an unidentified extinct branch of the human family tree that split off from the ancestors of modern humans before the evolutionary divergence that eventually produced Neanderthals and Denisovans. No fossil of this population has ever been found. No name exists for the species in the scientific literature, only its genetic echo, detected purely through mathematical analysis of modern DNA. At some point, tens of thousands of years ago, deep within the African continent, the ancestors of today's Yoruba and Mende people interbred with a now extinct human relative that science cannot yet identify in an event that left no skeletal trace anywhere except inside the genome itself. Some of the DNA inherited from this mysterious population appears to be far from random. The researchers found that certain segments were retained in modern populations at higher than expected frequencies, sitting near genes involved in functions like tumor suppression and hormone regulation, a pattern that suggests these ancient genetic contributions may have provided a survival advantage, spreading through the population not by chance, but because they helped. The same analysis noted faint traces of this same mysterious ancestry, showing up even in Han Chinese and European ancestry populations, though far less prominently than in the Yoruba and Mende samples, hinting that whatever this archaic population was, its genetic legacy may have rippled outward across a much wider swath of humanity than researchers initially expected. Suddenly, the mystery of Yoruba origins wasn't just about Ile-Ife or Oduduwa, or a founding migration from somewhere else in the historical era. It stretched back far deeper, into an entirely separate chapter of human evolution involving a species we don't have a name for, an event we can't date precisely, and a genetic inheritance that every oral tradition, every colonial ethnographer, and every historian arguing about Mecca versus Egypt versus heaven had no way of ever knowing existed. It's worth being clear about what this discovery does and doesn't claim. The ghost population, identified by Durvasula and Sankararaman, is a statistical inference, not a confirmed species with a fossil skeleton sitting in a museum drawer somewhere. Some geneticists in the years since have debated the exact percentage figures, the precise timing of the interbreeding event, and whether a single ghost population or several smaller distinct introgression events best explain the pattern in the data. That kind of scientific back and forth is normal, and it's ongoing. But the core finding that West African genomes, including Yoruba genomes, carry measurable ancestry from an archaic human lineage outside the known Neanderthal Denisovan family tree, has held up across multiple independent analyses since the original 2020 publication, and has pushed other research teams to search for similar signals in populations across the rest of the continent. For 500 years, the question of where the Yoruba people came from was fought over using legends, religious texts, and colonial-era theory, each version shaped as much by the politics of its time as by any real evidence. Genetics didn't just settle that argument. It revealed that the true story was simultaneously simpler and stranger than anyone had proposed. A species that no one has ever seen, named, or found. Think about what that means for the more than 100 million people around the world today who carry some connection to Yoruba heritage, from Ibadan to Bahia, from Lagos to Havana. Their ancestors built one of West Africa's great civilizations, survived a forced diaspora that scattered their language and religion across 3 continents, and, without ever knowing it, carried forward a genetic inheritance from a human species that vanished from the fossil record entirely. The history written in Yoruba DNA didn't come from Mecca. It didn't come from Egypt. In one sense, it didn't even come from what we would recognize as fully modern humans alone. It came from West Africa itself, layered and relayered over tens of thousands of years, holding memories no oral tradition was ever built to carry. And that raises a question worth sitting with. If a 5-century-old mystery about a single people's origin was hiding a genetic secret this old, this strange, and this well-preserved, what else is still waiting inside the rest of the human genome in populations we haven't studied this closely yet? If
kí ni mo sọ fún yín a gbọ́dọ̀ dúró de ìjọba bàbá nìkan ṣe bíbẹ̀ kọ́ Fúlàní wà wulẹ̀ wa lọ wa a nígbà tí dúró de ìjọba.
mo rò pé gbogbo wa láti wò ó, gbogbo wa láti gbọ́. Ojú wo lẹ fi wò ó? Báwo ló ṣe rí lọ́dọ̀ títí yín? Tó bá jẹ́ nǹkan tí mò ń rò lẹ́yìn náà ń rò ní, ẹ bá wa fílẹ̀ nínú comment section wípé Yorùbá ni mí, think Yorùbá first. Yorùbá ni mí kí n tó di Nàìjíríà nínú páálí. Ẹ jẹ́ ká gbé lárugẹ, ẹ jẹ́ ká padà sílé, ẹ jẹ́ ká think Yorùbá first.